Good morning students, myself Muhammad Jamil. In the previous class, in the engineering graphics and design, we have completed the sheet number 8. That is nothing but orthographic projection, in that projection of points using different quadrants. So, in today's topic, we are going to discuss about the projection of straight lines. So, whatever the topic, the projection concept which we have discussed in the previous class is in this also almost the same. So, the projection of point and line little bit similar in projection. So, what and how they are similar, that we are going to discuss in a problem when we analyze or imagine through that line. So, now in this section, in the sheet number 9, we have to discuss about the projection of straight line 1. So, here we have to show that the line parallel to both the reference plane. So, both the reference plane is nothing but here HP and VP are there in the projection. So, we have to represent the line is parallel to both the reference plane, that is HP as well as on the VP. Now, the second point in this is the line perpendicular or inclined to one reference plane. Means, as we know that we have HP and VP. So, in this a line, we have to represent a line should be perpendicular to any one of the plane, either it may be on HP or VP. When it is perpendicular to any one of the plane, how it is appear to the other plane as per the projection. So, at the same time, another topic is there, when the line is inclined, to any one of the reference plane, then if you view from the other side, how it will appear, that we have to project. So, we have to represent these two conditions. For these two conditions means, one is the line is parallel to both the reference plane, second one perpendicular, third one is inclined. These three conditions are there. So, in the projection of straight line, first of all we have to go through the theory. There is nothing but a line is a geometrical primitive that has length and direction but no thickness. Now, second point, a straight line is a locus of a point which moves linearly. Linearly, either it may be horizontal or vertical. Sometimes rotating in AutoCAD we will represent that. So, a straight line is also the shortest distance between two given points. As we know that this is, we already discussed this in the previous classes. What do you mean by a line? Means it is nothing but a shortest distance between 2 points. Now, next, the location of the line is projection quadrants is described by the specifying the distance of its ends. Suppose here I will tell you a line is there, a line is specified by its two ends, first end and the second end. In this we have given some text like A, B, or as per wish we will give R, S or P, Q. Like this we will give the text, that is nothing but name to a line. So, here this line we have to represent from point from the VP and HP. So, in this condition, so whether it may be HP or VP, the line may be as per our question, syllabus parallel to both the plane, first condition. Second, parallel to one plane and perpendicular to the other. So, here I will show you that, simply I will show when the problem I have discussed, at that time I will describe this in detail, I will explain that one. So, as per the first condition, the line is like this. So, if you see in the XY quadrant, it is appearing like a dot, it will appear like a dot. So, when we rotate this one, the line is representing, the line is parallel to both the reference plane. If you view from the front view, we will get the true length on the VP. If you view from the top, we will get the true length on the of the pencil, then the true length of the line on the HP. So, it depends upon how much it is above the HP and how much it is in front of the VP. But when a line is parallel to both the plane, we will get the true length on both the reference plane. Now, second one, parallel to one plane and perpendicular to the other. Suppose this is the line, if I placing like this, so it is parallel to one plane and perpendicular to the other. If I rotate this one, so the line is parallel to VP and perpendicular to HP. If I place this, if I change the direction of the line in this way, if I place in this condition, what will happen? The line is perpendicular to the VP and parallel to the HP. So, here any one of the reference plane is saying, so because of that I am showing you two planes, same condition, parallel is there, parallel to VP, we will appear like it will appear like a dot on the VP when it is perpendicular to VP. So, when it is parallel to VP, we will get the true length on the VP and dot on the HP. In the same way, if I place like this, what will happen? Dot is here, dot is on the VP and true length on the HP. Now, parallel to one plane and inclined to the another. If I place like this, if I place the line inclined to HP, means it is whenever the line is inclined to HP, it is appearing on the VP. So, the inclination line we can see from the front view, the true length we can appear on the VP. But when we view the same object from the top, due to that inclination we cannot get the true length, but we can assume that we can see that the line is parallel to the HP. So, it is not showing you the true length because of its inclination, that we have to represent through the projection. So, these are the things we have to represent or we have to draw this in this topic. So, the next thing, projection of line parallel to both HP and VP. In this, if you see the blue color line, this one AB is, just now I told you, I have shown you, line is parallel to both the reference, that capital A and capital B, that the upper letter A and B is the actual text given to the length, that is the real one. But when we project that, how it is appearing, the true length of this AB is appearing here, A complement, B complement, the brown one from the front view. When we view from the top, this line 70 mm, if you see the 70 mm, yes, above the HP and 60 mm in front of the VP. 80 mm is nothing but here it is showing the length of the line. So, here if you see that blue color line is appearing A complement, B complement from the front view, about 70 mm is given, 70 mm above the HP, A complement, B complement, this is the true length from the front view. If you view from the top, that A complement B, AB is appearing like a small a and small b, there is see here A and B, which is 60 mm in front of the VP, through the reference line 60 mm in front of the VP. If you view from the side view, because if you view from this side, how it is appearing, the line is appearing like a dot, just like a point. So, the point is representing how much it is representing, it is 60 mm in front of the VP and 70 mm above the HP. This point is there, this is 60 mm, 70 mm above the HP, in front, above the HP and 60 mm in front of the VP. That we can represent with the help of the second reference line, that is x1, y1, we are taking another reference line. To represent the side view A double complement, B double complement, we have to draw an inclined line by making an angle 45 degree with the second reference line. So, after that we have to project this line from the B up to this point and from A up to this point. So, whenever this inclined line, when we meet this line, we have to draw a vertical line. Wherever this line and this line coincide, that nothing but point where both the lines meet, we have to put a point. This point is nothing but our side view when we view from the side. So, this is the condition, assume that one like this, parallel to both the plane, above the HP, in front of the VP. It is representing like this as we discussed. But when we view from the side, is appearing like 70 mm above the HP and 60 mm in front of the VP. If you view from the front view, that is nothing but from the side view, I am showing you the side. Is it appearing like a line or a dot? Dot. How? What is the position of this one? Point 70 mm above the HP and 60 mm in front of the VP. That is our double complement. I am representing the side view, that is left view. I am viewing from the left. So, here left view I am representing. I am seeing from the right, but I am representing on the other side. So, this is the way of representing the side view. So, double complement represent the side view. So, this diagram, by the help of the same command, line command, we have to use the line command and the point shell. By this we can complete this diagram. So, if you want, we can draw this line in AutoCAD also. Suppose here is the AutoCAD line, I am drawing a line here like this. Next, one of the end of the line is 70 mm above the HP. Okay. Again the same, another end of the line is showing 60 mm in front of the VP. So, this and this, both the lines I will change the bilayer to yellow because they are the projection lines. Now, L enter. From here to here the length of the line is 80 mm. So, here also I will draw the same line. If you view from the both the side, either on HP or VP, the true length is same. L enter. From here to here is 80, enter, finish. So, by this we have completed our answer, but we have to draw the projection lines again. L enter, from here to here. So, here the dimension is also there. I will go through the linear dimension. This is the true length. Mm. Now, we have to draw the side view, left side view. If we want to draw the left side view, we have to draw another reference line. Again, we have to draw the inclined line by making an angle 45 degree, 100, tab 45. So, by this I have drawn a line. If you see this red color line, this is the line. This is the reference line, this is the inclined line by making an angle 45 degree. Now, we have to represent the side view. To represent the side view, first of all I am drawing a reference another line, projection line from there, and another line from here, here to here up to this one. So, this is not a correct one because the line is wrong. So, here we can draw this one. If you see, again the same thing has happened. What I will do, I will just drop to here. Now, from this point I will go for trim, TR double enter. Okay. Now, again L enter. Now, from this point to up to this point. So, this is TR double enter. See, wherever this both the lines coincide at this point, this is nothing but my side view, wherever I am representing that as a point. If I view the object from front view, it is appearing like this. If I view from top view, it is appearing like the same true length. But when I view from the side view, that line is appearing like a dot, which I am representing here. So, this is about the problem when a line is parallel to both the reference plane. So, now next condition, the line parallel to a plane. Simply whenever the line is there, suppose AB is the line, when it is parallel to any one of the plane, it will show the true length to that one only. So, here I have taken from the front view. So, the true length is appearing on a VP, that is nothing but A complement, B complement representing the object is appearing on the VP. Next, the line is inclined to a plane. So, just now I told you this is our HP and this is our VP, and this is the line, AB is the line which is making an angle theta with the HP, and when we view from the front view, it is appearing like this. So, by making an angle theta. So, it is appearing when we view from the front view, this is the true length, but when we view from the top, only this much length is showing. So, the true length is on the VP because the inclination figure, the complete length we are getting on the VP. No need to represent the line which is parallel to this one because it is an inclined line, so it will not give the true length. So, because of that we are representing A complement and B complement as the true length of this inclined line. Line perpendicular to HP and parallel to VP. Perpendicular to HP and parallel to VP. Here A and B, blue color line is the actual real line. This is parallel to VP and perpendicular to HP. So, whenever the object, when we view from the front view, the line is parallel to VP, it is appearing the true length which is at the red color line, which is 60 mm in front of the VP and 30 mm above the HP. So, here if you see the red color line, when we view from the front view, from this way, if we view from the front view, this blue color line is appearing as a red color line which is the true length, and this is the front view. That A complement, B complement which is on the VP is appearing the front view. And if we view from the top, when we view from the top, AB is representing like A in bracket B, this is the top view, which is appearing like a dot. And when we view from the side means if we are viewing from this side, the line which is parallel to VP, exactly the true length we are getting on the HP, side view, that is A double complement, B double complement. This is the side view when I am viewing from this one, which is represented with the brown one. See, A double complement, B double complement. The line 30 mm above the HP, and B, we can call it end B is 30 mm above the HP, and the length of the line is how much? 80 mm. Now, when we view from the top, A and B, just like a dot, and when we view from the side view, A double complement, B double complement. How we are getting that? By drawing another reference line, making an angle 45 degree, and with the help of the projection line. So, dot, if we are projecting the dots, here M is we are representing. Now, when we are projecting the A complement, B complement, and that same line is projecting here and here, both the lines are coinciding with this line. So, because of that, we are getting the true length here also, side view of that object. Okay. So, by this we have completed another problem. So, here now we are going to the problem. Just I will draw that one here. A 70 mm long line a 70 mm long line is there, whose name is RS, is parallel to both the planes HP and VP, 30 mm in front of the VP and 40 mm above the HP. Now, suppose this is the reference line I am taking now in the quadrant. So, in the first quadrant, the line is parallel to both the plane. It is appearing like a dot. So, this is I am representing as RS. So, if I want to represent this in a reference line XY, the line is parallel to both the 30 mm above the HP. From here to here, suppose this is my 30 mm, this is my R complement, which is 30 mm above the HP. Now, it is parallel to both that one R S complement. So, if you see, this is the above the HP, that is 30 mm above the HP. If you view from the front view, it is appearing like that. Now, in the same way, 40 mm below the HP, above the 30 mm in front of the VP and 40 mm above the HP. So, this is our 40 mm. Now, this is our 30 mm R S. Now, from there I have to draw an angle by making a reference line. From this reference line 45 degree I am taking. Now, if I project this one, this is my that point, another, that is the R double complement S double complement, but this is not given in the question, but I am showing you the side view. This is the side view of that point. Now, this point we have to draw in AutoCAD. L enter, again L enter. The question is 40 mm above the HP, 40 mm above the HP, 30 mm in front of the VP, length of the line is 80, these are the projection lines, whichever I am changing the line. These are nothing but our projection lines. Now, after that we have to go for the dimension, linear, 40 mm above the HP, 30 mm in front of the VP, and the true length is here. This is nothing but, as we know that this is our text RS, length of the line we have given as R and S. So, this is my R complement S complement R S, that is it. So, now the next problem. We are going to see the next problem. In this, if we see a 50 mm long line is there, whose line RS 30 mm above the HP and the line is perpendicular to HP and 45 mm in front of the VP. Draw its projection. As we know that simply, first of all, what are the conditions given? First we will see that. Again I will show you that one. 50 mm is the length of the line and its end is 30 mm above the HP and the line is perpendicular to HP and 45 mm in front of the VP. Now we have to draw this diagram. So first of all, we will represent like this. So in this 30 mm above the HP is there. The point, suppose this is the point, that is R, 30 mm above the HP, and the line is perpendicular to HP. Line is perpendicular to HP means, no, this is the line R and S. So this is my x axis, that is nothing but HP. This is nothing but my VP. Y axis, that is nothing but VP. Now how much it is in front of the VP? Suppose this is 45 and this is 30 mm. Now I have to draw this diagram. When I view from the front view, the lines appearing on the VP, that is 30 mm above the HP. When I view from the top, the length of the line 50 mm is appearing like a dot here, because the line, when we view from the top, instead of its length, it's representing with a dot. That's it. So this diagram we have to draw in the AutoCAD. Now on this only I will represent that. L enter, 30 mm above the HP, again enter, 45 mm in front of the VP. So this line and this line, both lines are my projection lines. So I can project with the different colors as per my choice. So here again I have to go for the line, L enter. From this line, the length of the line is 50. From the dimension linear, 50 mm true length, 30 mm above the HP, 45 mm that, and it is representing from the top view as a point. Finish. If you see the line which is in the first quadrant, 30 mm above the HP, and the line is parallel to the VP. So this one is our VP, that line is appearing on the VP. So this R complement S complement, here R comma S. Because it is appearing on the VP, I have put a complement there. Because this is representing or appearing on the HP, I have put it simply the alphabet. That's it. By this, we have completed our topics. Okay. So this is the small topic from the projection of straight line 1. In the next section, we are going to start projection of straight line 2, in which we are going to discuss about the line is inclined to both the reference plane. So in that we will solve at least one problem and we will discuss some theory in that. Okay. By this we have end this section, and the projection of straight line 1 section is completed from this, by this topic. Okay. Thank you.